Good evening, everybody. I mean, there's nobody here, but whoever is watching this recorded video, uh, good evening to you. Uh, so, since nobody has joined in, I'll get started with the live session. So, this is the eighth live session, and we'll be discussing. We had finished discussing week four's questions related to week four, and today we'll discuss week five questions related to reflexes, M response, H response, and all those topics. So the format remains the same. I'll go through the MCQ questions, and then you can try and solve the MCQ question, and then I'll discuss each of the options of the MCQ in detail. Uh, so we can get started now. Okay. So this is the first question. Just see if my mic is on. Yes, my mic is on. So this is the first question. 1A interneurons are inhibited by 1A afferents of the agonist muscle, Renshaw cells, 1A afferents of the antagonist muscle, or D motor neurons. So you can pause the video, try and answer this. Okay. So let us recall what the situation is. So let us consider a joint here, and we have a muscle here, and we have another muscle here. So this is the this is consider this is an elbow joint, and this is the flexor muscle, and this is the extensor muscle. Uh, so we have these primary spindle endings here, and primary spindle endings and secondary spindle endings, which are connected to the 1A afferents. Uh, and these 1A afferents are so one thing to remember is that the afferents are always excitatory. So we have another interneuron here, which is the 1A interneuron, and this is the 1A afferent. And then we have the alpha motor neuron here, which supplies the this the antagonist muscle. So let us assume that there is a stretch in this muscle. Uh, so this is the agonist, and this is the antagonist. So if there's a stretch in this muscle, the 1A afferents fire, uh, and when this stretch could be because of contraction of this antagonist. So when this, let us say this contracts, this it leads to the stretching of this, and then we have these action potentials that are generated, these signals that are generated, and so the 1A afferents uh, excite the 1A neuron, and the 1A interneurons are inhibitory are inhibitory neurons. So then they inhibit, they give inhibitory signals to the alpha motor neurons of the antagonist muscle, so that it decreases its contraction. Uh, now, this is one scenario. The other scenario is we have alpha motor neuron which supplies this agonist muscle, and this alpha motor neuron excites Renshaw cell. So this is a Renshaw cell, which the Renshaw cell which inhibits the alpha motor neuron that excites it, and uh, it also gives inhibitory inputs to the 1A interneuron. Uh, so this is a feedback mechanism. So when the agonist contracts, what happens is the alpha motor neuron that caused the contraction also excites a Renshaw cell. So this is the Renshaw cell. So it excites the Renshaw cell, and what the Renshaw cell does is it inhibits the alpha motor neuron that excited it. So this is a form of negative feedback, and the Renshaw cell also inhibits the 1A interneuron. So this is so since it is inhibiting the 1A interneuron, so the inhibitory effect of the alpha motor neuronal pool of the antagonist is decreased. So the probability that this can be excited increases. So essentially, if this contracts, then the probability that the antagonist muscle can contract to counteract this. So this is a form of negative feedback. So that probability increases. So again, this is a form of uh, control mechanism. This is also negative feedback. So the answer here is the one. Hey, you can keep this in mind, this explanation in mind, and we can answer many questions in the follow-up MCQs as well. So the 1A afferents of the 1A interneurons are inhibited by no by the 1A afferents of the agonist muscle. No, the agonist muscle does not inhibit. The 1A afferents do not inhibit; they always excite. The Renshaw cell, that is correct, and the 1A afferents of the antagonist muscle. No, motor neurons. No. So the answer is B, Renshaw cells. Uh, moving on to the next question. Question 2. 1A interneurons inhibit the alpha motor neuronal pool of the agonist muscle that excited it. B. Inhibited the alpha motor neuronal pool of the antagonist muscle. C. Excite the alpha motor neuronal pool of the agonist muscle that excited it. Or D. Excite the alpha motor neuronal pool of the antagonist muscle. So again, you can just pause the video, take a couple of minutes, and try to answer this question. You can have a look at this explanation here. This will give you an idea of what the answer should be. Okay, so has anybody joined in? No. Okay. Uh, the 1A interneurons, first of all, we need to remember one thing. The 1A neurons are always inhibitory. So the 1A interneuron inhibit the alpha motor neuronal pool of the agonist muscle that excited it. So we can see that the 1A interneuron is actually inhibiting the alpha motor neuronal pool of the antagonist muscle, not the agonist muscle. Okay. So this is the wrong answer. The agonist muscle is the wrong answer. Inhibit the alpha motor neural pool of the antagonist muscle, yes. Excite the alpha motor neural pool of the agonist muscle that excited it. Excite the alpha motor neural pool of the antagonist muscle. No, so these two are wrong. We know that they don't excite. So the answer is C, B. Okay. When a small amplitude external stimulus is provided to induce a monosynaptic reflex, the alpha motor neuron gets activated before the 1A afferents because so there's a typo here. Okay. When a small amplitude external stimulus is provided to induce a simple monosynaptic reflex, the alpha motor neurons get activated before the 1A afferents because alpha motor neurons are large diameter neurons. The 1A afferents get activated before alpha motor neurons because the 1A afferents are large diameter neurons. Both 1A and alpha motor neurons are activated simultaneously. No response is seen because reflex is observed only when amplitude of stimulus is very large. So let us consider a situation. So we have this system here. So this is a muscle spindle, let us say, and these are the afferent fibers that take information from these spindle to the to the spinal cord, and these are the efferent fibers, and this is the muscle. So these efferent fibers are what cause uh, contraction in the muscle. So these are the alpha motor neurons or the gamma motor neurons, and uh, afferent fibers are the 1A afferents or 1A or 2 afferents or 1B afferents. So let us consider. So we are trying to give us external stimulus. Okay, and so this is this is basically a nerve, and this nerve will contain both afferent fibers and efferent fibers. So what happens is when this external stimulus is given, there is depolarization that happens in uh, uh, all the fibers within the nerve. However, uh, since the 1A afferents, the 1A afferent fibers have a larger diameter, so they get depolarized. They get depolarized to threshold first, uh, and this is what causes the H reflex or the Hoffman's reflex. Uh, so if we keep increasing the amplitude more and more, if we keep increasing the amplitude more and more, uh, then more and more afferent 1A fibers will get activated, and then eventually even the alpha motor neurons or the efferent fibers start getting stimulated or activated to threshold. So the answer is the 1A afferents get activated before alpha motor neurons because 1A afferents have a larger diameter neuron. So the answer is B, and we can think about it this like this. So V is equal to IR, uh, and V by R is equal to I. So for larger diameter fibers, the R is less. So for the same voltage, since the R is less or the resistance is less, the membrane resistance is less. The input current that will go into these 1A afferents will be more. Since R is small, the I will be high, and this since a larger current goes in, the depolarization will be larger, hence causing that particular uh, fiber to reach threshold and cause an action potential. So this is one way of thinking about it. Which of the following is true regarding the latency of H reflex? The latency decreases with increasing amplitude of stimulus. Latency decreases with decreasing amplitude of stimulus. Latency remains the same and is independent of amplitude of stimulus. Latency might increase or decrease with increasing stimulus. Uh, so let us recall what happens. Uh, so the situation is like this. Let us go back to this. So the 1A afferents, this is, let me just erase this. So you have the muscle here. You have 1A afferents from the muscle spindle. And these synapse with the alpha motor neurons, 1A afferent, these synapse with the alpha motor neurons and cause excitation in the same muscle. Okay, so when this stimulus is given, uh, it causes an action potential in this 1A afferent, and these action potentials travel, and there is one synapse that is involved, and then it travels. So there is a conduction, an efferent conduction Ta plus a central processing time to process this. So there's one synapse involved. So there's a delay, synaptic delay. So let us call this the central delay, and then an efferent uh, an efferent conduction delay of the action potential. So this is the latency. So when this gets stimulated, this is the latency that is involved. So this latency does not change, is independent of the amplitude. As long as this gets excited, the path that the action potential needs to, as long as this reaches threshold, the path that the action potential needs to travel to cause the reflex is the same. To cause the H reflex is the same. Uh, so it is the latency remains same and is independent of the amplitude of the stimulus. Answer is C. M response is observed because the 1A afferents and the alpha motor neurons undergo a structural change resulting in a new response. Increase in stimulus strength has resulted in excitation of efferent fibers. Uh, Antidromic conduction in alpha motor neurons results in faster muscle contraction. 1A afferents excite alpha motor neurons. Okay, let us look at the situation here. So again, it's the same. Can I copy this somehow? Okay, so I'll just explain from this figure itself. So what happens is for the M response, as the amplitude of stimulus keeps increasing, uh, the 1A afferents are anyways firing, causing the H response. But after some time, the amplitude is big enough to even uh, cause an excitation, cause an action potential directly in the alpha motor neuron itself. So an excitation will be caused in the alpha motor neuron, and that excitation will travel towards the muscle, and causing the M response. So the latency will be like this. So this is what it look like. So this will be the M response, and then this will be the uh, M response and the H reflex. So obviously the latency of the M response will be less. So this is the stimulus because it does not need the path it needs to travel is lesser. However, for the M response, it needs to travel through a synapse as well, and plus there is TA, that is the conduction time for in the afferent fiber. Plus there is TC and TE, but for the M response there is only TE, that is the conduction time involved in the efferent fiber, that is the alpha motor neuron. So let us go back to this. The 1A afferents and the alpha motor neurons undergo structural change resulting in a new response. No, increase in stimulus strength has resulted in excitation of efferent fibers. Yes, this is correct. Antidromic conduction in alpha motor neurons results in faster muscle contraction. No, and 1A afferents excite alpha motor neurons. No, that is not the reason. That is the reason for H reflex. So the answer is B. Moving on to the next question. For a monosynaptic reflex, M response increases and then decreases with continuous increase in stimulus strength. H reflex increases and never decreases with increase in stimulus strength. M response decreases and increases in decreases with increase in stimulus strength. H reflex increases and then decreases with continuous increase in stimulus strength. So you can take a couple of you can just pause the video and then try and respond to the question. Okay, so let us look at the situation here. So what happens here is, let me just redraw that diagram. So we have a muscle, we have these one A afferents, we have alpha motor neuron. Uh, so what starts to happen is initially when there is a increase in the stimulus amplitude, the H reflex starts to first only the H reflex is seen. then it starts to increase in amplitude, and then after a time M response also becomes visible, and then M response continues to increase with increase in stimulus amplitude, and as after a certain time the M response continues to increase and the H response starts to decrease. So uh, we have an action potential that is traveling like this in this direction. Okay, so this is uh, orthodromic conduction. If you recall antidromic and orthodromic. So this is orthodromic, and then we have the M response here. So there are two kinds of since it is the action potential is first initiated at this particular location. There will be an orthodromic conduction towards the cell body, and there will be an antidromic conduction. Sorry, this is called an antidromic conduction that is towards the cell body, and this is called an orthodromic. That is away from the cell body. Uh, so this is what this orthodromic conduction is what causes the M response, and this and now what starts to happen is the action potential that is coming in from the 1A afferents will excite this particular neuron here, that is the alpha motor neuron. But what happens is there's also an antidromic conduction that is happening in this direction. So the action potential, the excitation caused due to the 1A afferents in the alpha motor neuron and the antidromic conduction of the action potential both meet at this particular location and they extinguish each other due to the refractory period. So both of them cannot travel forward. So this cannot go further here, and the 1A afferents the action potential caused due to the 1A afferents cannot go further down. So they extinguish each other. Hence, although the M response is visible because of the orthodromic action potential, conduction of the action potential, the antidromic conduction of the action potential extinguishes the action potential caused due to the 1A afferents in the alpha motor neuron. So hence the H response starts to decrease with an increase in stimulus amplitude because more and more alpha motor neurons start to get recruited directly, and hence uh, the number of uh, uh, afferents that are the action potentials that are generated due to the 1A afferents start to get extinguished more and more. So the answer is uh, the H reflex increases and then decreases with continuous increase in stimulus strength. Answer D. Yeah. So which of the following is true for a T reflex? Nobody has joined in yet. Okay. We'll discuss this question. Which of the following is true for a T reflex? A. T reflex is analogous to H reflex, but latency is higher for a T reflex. A T reflex is analogous to M response, and latency is also same as M response. T reflex is analogous to H reflex, but latency is lesser than for a T reflex. A T reflex is analogous for H reflex, and the latencies are also same. So let us look at what a T reflex is. So the situation is the same here. We have a 1A afferent. We have a muscle here. This is a muscle spindle. Uh, so this 1A afferent excites an alpha motor neuron, which so this is basically a monosynaptic reflex. So what happens is when there's a tendon tap, or there's a quick stretch in the muscle, the 1A afferents, the primary sensory endings of the 1A afferent starts to fire, which are very sensitive to these quick stretches, and they in turn excite the alpha motor neuron, which in turn contracts the same muscle. So this is the T reflex. So we can see that this is similar to the H reflex, and the path that it follows is also similar to the H reflex. Only the way the 1A afferent is stimulated is different. In the H reflex or the Hoffman reflex, the stimulation of the 1A afferents was done externally, but in the T reflex, it is done. In the H reflex, it was done using electrodes, but in the T reflex, it is done using a quick stretch or a tap of a tendon, which can cause this stretch. So the answer should be D. T reflex is analogous to H reflex, and latencies are also the same. Upon increasing the frequency of stimulus, H reflex remains same, M response increases. M response remains same, H reflex increases. H reflex remains same, M response decreases. M response remains same, and H reflex decreases. Okay, so let us recall what the situation is. So we have the stimulus that is continuously given. So what happens initially is that uh, there is M response, and let us assume that the amplitude of this stimulus is enough to induce an M response as well as a H reflex. Now, when the second stimulus comes in close proximity, uh, what happens is, let us recall that uh, there is a synapse involved in the H reflex, and this synapse involves releasing of neurotransmitters, and there are chemicals involved. So that's a slow process, and then the neurotransmitter again needs to be taken back into the from the synapse into the presynaptic membrane, and then they need to be packed in vesicles. So this is a time consuming process. Whereas for the M response, uh, the there's no synapse involved. Uh, there's no central synapse involved in the M response. So the only factor here is that it needs to come out of its refractory period. Only then it can be stimulated. So the time that the M response takes to come out of the refractory period is much lesser than the time the synapse takes to again be ready for to generate an action potential across the synapse. So what happens is when there's the frequency of the stimulus is increased, the M response continues to uh, generate. The M response is there. However, the H reflex response continues to decrease because it is not able to uh, generate those action potentials, because like I just mentioned, it's a time consuming process since chemicals are involved. So the answer is M response remains the same and the H reflex decreases. Answer is D. Renshaw cells A cause disinhibition of alpha motor neuronal pool of the agonist muscle that excited it, cause inhibition of alpha motor neuronal pool of the antagonist muscle, cause inhibition of alpha motor neuronal pool of the agonist muscle that excited it, or D cause disinhibition of alpha motor neuronal pool of the antagonist muscle. So again, you can just take a couple of minutes to answer this question. Uh, so let me just discuss this. Let me go back to the first slide. And if you look at the scenario here, what happens is, so the alpha motor neuron, when it fires to cause a contraction in the agonist, it also causes an excitation in the Renshaw cell, and the Renshaw cell inhibits the alpha motor neuron that excited it. So this is one condition, one situation, and then the alpha motor, the Renshaw cell also inhibits the 1A interneuron, which causes inhibition of the alpha motor neuron. So the uh, alpha motor neuron is the 1A interneuron causes inhibition of the alpha motor neuron, but the inhibitory effect of the 1A interneuron itself is decreased because the Renshaw cell inhibits the 1A interneuron. Uh, so let us go back to that question. So this situation is called disinhibition. So the overall effect is that the probability of the alpha motor neuronal pool of the antagonist muscle, the probability that it will go to that it will get excited increases. So the answer is uh, causes inhibition of the alpha motor neuronal pool of the agonist muscle that excited it. This is correct. And causes disinhibition of the alpha motor neuronal pool of the antagonist muscle. So the answer is C and D. Let us go to the next question. Which of the following statements is true for a monosynaptic reflex? The H reflex occurs at a higher latency compared to M response. At higher stimulus strength, alpha motor neurons are recruited, resulting in a M response. M response occurs at a higher latency because the path is longer with more synapses. The M response decreases with increase in stimulus strength. Uh, So we know that this is correct. We have seen at higher stimulus strength, alpha motor neurons are recruited, resulting in an M response. This is what this is the definition of an M response. And the H reflex occurs at higher latency compared to M response. This is also correct because we have seen that there's a extra synapse, a central synapse involved in the H reflex. Plus, there is conduction time of the extra conduction time of the afferents as well. Uh, so the answer is A and B. And if you see C, RAM response occurs at a higher latency because the path is longer with more synapses. That is wrong. That is the answer for the H reflex. The M response decreases with increase in stimulus strength. Again, this is true for a H reflex, not for a M response. Okay, now coming back, going to 1B interneurons. So again, this is another interesting topic. So 1B interneurons A inhibit the homonymous muscle through a oligosynaptic pathway involving 3 synapses. This inhibit the antagonist muscle and is polysynaptic involving 4 synapses. Inhibits the homonymous muscle through oligosynaptic pathway involving 2 synapses. or disinhibit the antagonist muscle through a oligosynaptic pathway involving three synapses. So let us just look at what the situation is here. So we have a muscle here, and then we have this muscle here, and we have these Golgi tendon organs. So we have seen the situation where we have a negative feedback when the muscle stretches. So when there's a muscle stretch, uh, we have this mechanism. Uh, we have two mechanisms here which causes the muscle to contract, or there's a negative feedback which opposes the stretch. Uh, one directly involves the muscle, and the other involves the antagonist muscles. So in this case, now the situation is, we let us consider a case when there is a contraction in the muscle. So now how can a negative feedback be provided to stretch this? So we have a contraction here, that is, let us assume that this is the muscle which is contracting. So we have Golgi tendon organs. We have a Golgi tendon organ that detects this contraction. So when the muscle contracts, causes a stretch in the tendons, and this stretch causes firing in the 1B afferents. So, so this is a 1B afferent, and uh, so now we know that afferents always cause an excitation, right? So we have a 1B interneuron here, 1B interneuron, and this 1B interneuron, what it does is, uh, it causes inhibition in the alpha motor neuron. So we have an alpha motor neuron here, alpha motor neuron. So when the alpha motor neuron fires, uh, it causes a contraction in this. So the 1B afferent, what it does is, it excites the 1B interneuron, and the 1B interneuron, uh, so since it causes an excitation in the 1B interneuron, the 1B interneuron has an inhibitory effect in the on the alpha motor neuron of the agonist. So we can see that there are two pathways here. There are two synapses, one synapse here and the other synapse here. So two synapses. So this is a oligosynaptic. This is an oligosynaptic reflex. So whenever two or more synapses are involved, then it's two or three synapses are involved, then it's an oligosynaptic reflex, and when it is greater than two, then it's a polysynaptic reflex. So it inhibits the homonymous muscle through a oligosynaptic pathway involving two synapses. So this is correct. We can see this here. So this answer is correct. And then what it does is, this inhibits the antagonist muscle through a oligosynaptic pathway involving three synapses. So let us consider one more case. So this is a form of negative feedback. Now we have this interneuron. We have one more interneuron here, and then we have this alpha motor neuronal pool. Of the antagonist. So now the what the 1B interneuron does is it inhibits another inhibitory interneuron of the alpha motor neuronal pool of the antagonist muscle. Uh, since the inhibitory effect of this interneuron is getting decreased because of the inhibition of the 1B interneuron, so the probability that this alpha motor neuronal pool will get excited increases. So this is a form. This again causes a contraction in this, or the probability that this will contract increases. The antagonist will increase. The probability that the antagonist will contract increases, uh, and hence it will oppose the action that was caused due to the contraction of this agonist muscle. So again, this is a form of negative feedback. So this is called disinhibition. This uh, part here. So it is inhibiting the inhibition of the antagonist muscle. So that is called disinhibition. So the answer is disinhibits the antagonist muscle through a oligosynaptic pathway involving 3 synapses. So we can see 1 synapse here, 2 synapse here, and the third synapse here. 3, 2, and 1. So the answer is C and D. So we have question 13, Hertz reflex. Amplitude can never be changed. Amplitude can be changed by voluntary activation. Amplitude can be changed by training, and latency can be reduced significantly by training. Uh, so experiments have shown that the amplitude of the Hertz reflex can be modulated by voluntary activation of certain muscles, and they can also be changed by training. So the answer is B and C. Moving on to the next question. So the F wave has latency greater than that of Hertz reflex, latency same as that of Hertz reflex, latency in between M response and Hertz reflex, latency greater than M response. So let us recall the situation of how an Hertz reflex is, an F reflex is generated. So this is an alpha motor neuron, and let us say we cause a stimulation here. Okay, and this stimulation causes antidromic conduction of action potential in this direction, and then orthodromic conduction of action potential in this direction. So the orthodromic conduction of action potential causes the M response, and this antidromic conduction of action potential can sometimes due to some peculiarities in the timing uh, of the refractory period. In some situations, it is seen, in some cases, it has been seen that this again causes an action potential, generates an action potential, uh, and causes an action potential to travel down. So this antidromic action potential causes an orthodromic action potential causes an orthodromic action potential, which causes the F response. So we have the situation here. So first there is an M response, and then there is an uh, F response. However, we know that in the case of the Hertz reflex, there is an additional synapse that is involved. So there is an additional delay. So the F response is still, the latency of the F response is still lesser than that of the Hertz reflex. So the answer is the latency is in between M response and Hertz reflex, and the latency is greater than M response. So the answer is C and D. We have two more questions. Okay, so these questions are slightly bigger, so we'll discuss them in the next class. So we'll stop the session here. Uh, okay, so see you guys next week, and we'll continue discussing MCQs. So we'll discuss these two questions next week, and then uh, we'll start with week 6, discussing week 6 MCQ questions. Okay, thank you. Bye.